Hello and welcome to AP Chemistry class, and this will be understanding periodic table. As you see, periodic table is arrangement of elements, and it starts with 1, which is hydrogen, and second is helium, so on and so forth. It's arranged in a chronological order. Total number of elements is 118, and as we see, all the elements are represented either as a single letter, for example hydrogen by H, and some of them by double letters, which can be usually the first two letters of the element, for example calcium as Ca, but it is not the case always. For example, for iron it could be Fe, and for lead it is Pb. So one more thing is you see a number above the element. For example, for hydrogen, I see 1 and also a decimal number below it. So what are these two? Let's understand that the number above the letter is the atomic number. Atomic number means number of atoms in the nucleus, which is the protons. Number of protons is equal to the number of neutrons. So what's the number below? It's the atomic mass, which is the mass of the particular element. Simply the mass of a atom of hydrogen. Understanding what's molar mass, what's a mole? So mole is a counting unit, a system to measure how many number of atoms are available in that molecule. For example, you can be taking any substance. You need to know how much quantity of it is taken. So if I, for example, take eggs, I could say I have taken a dozen eggs. That's how we do counting. And we have this Avogadro number, which is a very huge number, 6.022 into 10 to the power 23. That's how many particles are there in every molecule. It's a huge number. So we need to convert from one unit to another, say grams per mole, to find the mass of any compound. For example, we'll be taking the example of carbon dioxide, finding how many grams per mole of carbon dioxide are there, how many particles are there in carbon dioxide, and so on and so forth. So that's what our calculations are going to be. There'll be a little bit of calculations as we move forward, and we'll be finding how many particles are present in an atom of carbon dioxide. Molar mass. Here's an example of a molecule of sodium carbonate. So here the chemical formula for that being Na2CO3. Carbonate has a formula CO3, and sodium is represented by the alphabets Na. So we need to find what is the atomic mass of sodium, multiply that by 2. So 46 is present because 2 into 23 equals 46, and 1 into 12 is 12. So 12 of carbon is present. 3 into 16 of oxygen, which is 48. So total molar mass will be equal to 106 grams per mole. The molar mass of carbon dioxide. Carbon dioxide, that means 2 atoms of oxygen are there. So the molar mass of carbon dioxide will be the mass of carbon, which is 12, plus mass of oxygen plus mass of oxygen 2 times. So it would be 12 plus 16 plus 16, which is 44.01 grams per mole. And this image is given by Geeks for Geeks. It's an amazing website. Please do refer to that. Thank you. Avogadro's number. Remember the analogy between a mole and a dozen. When I refer to dozen of x, it means I am referring to 12x. And similarly, Avogadro's number is a huge number, which is 6.022 into 10 to the power 23 particles, which is called the Avogadro's number. Is a very large number. So that many particles are there in a mole. That's what we're referring to. Next, we'll go for dimensional analysis. Converting from one unit to another for analysis purposes, for example, converting miles per hour. In the US, we have miles per hour, but in India, the metric system of measurement is meters, kilometers, and hours, seconds, minutes. So some other people may be using inches, centimeters. So we need to convert from one to another. This was there in mathematics in earlier years. So you have already done. So it's the same thing, the conversion factors. Converting from one unit to another unit. 1 foot equals 12 inches. 1 meter equals 3.28 feet. This is done for analysis purposes. And carbon dioxide, converting from grams to moles. Say for this purpose, I'm taking 50 grams of carbon dioxide and I multiply by 1 mole of carbon dioxide divided by 44.01 grams of carbon dioxide, which is 1.14 moles of carbon dioxide. Mole value calculations. Tips for that is we need to memorize this formula which says that moles is equal to grams divided by molar masses. So that's the conversion that we use in this problem using the concept. You're ultimately dividing the number of grams you have by the molar mass to get the number of molecules, moles. Moles to atoms. Carbon dioxide converting from moles to atoms. So we have 1.14 moles of carbon dioxide into 6.022 into 10 to the power 23 atoms of carbon dioxide divided by 1 mole of carbon dioxide, which is equal to 6.84 into 10 to the power 23 atoms of carbon dioxide. Here we are factoring in the Avogadro's number for conversion purposes. So let's review the entire topic. We earlier saw about what atoms are in a previous video, for which I can give the link in the description below. You can go through that completely, explaining what is atom, what is proton, neutron, and electron. We went through in great detail. And we also saw what is atomic mass, which is mass of an atom of any element. This you get it from the periodic table. And we also saw what atomic mass units is, which is the standard to measure, and it is nothing but mass of proton or neutron. We also saw what Avogadro's number is, which is 6.022 into 10 to the power 23 particles per mole. We also saw what conversion factors is, converting from one to another unit, be it miles per hour, or you can use meter or kilometers per hour or minutes. And we have several others like inches, foot, centimeters, etc. I hope this topic was useful for all of you. Please stay tuned for more such topic. Do subscribe, like, and share it with your friends. Thank you.